How do we manage the protein transition? Which food components can provably boost your immune system? What's the best way to validate health claims for food and food components? Listen to our food and health experts discuss the biggest questions facing the food, nutraceutical, and food ingredient industries today. Welcome to NIZO Talks Food and Health.
One-third of the food produced for human consumption is lost or wasted every year. This makes proper food safety and chain control in food development and production a key aspect of reducing food waste. Microbiology and food safety expert Robyn Eijlander from NIZO discusses how to ensure and control microbial quality when adding novel ingredients or probiotics or adapting processes. Globally, one-third of the food produced for human consumption is being wasted, and that is usually due to spoilage and microorganisms. Today I'll be talking to Robyn Eijlander. She's an expert on food safety and microbiology, and we'll be discussing the effects of food safety and chain control in the food supply. Robyn, welcome. What microbial safety challenges crop up when you develop novel products?
Well, I think what's important to realize is that consumers continuously demand newer, healthier, better foods. And what the food manufacturers do is they try to meet that demand by continuously changing ingredients and food formulations and even processes. And so what that does is it really opens up the door for novel microbial contaminants, or maybe even existing ones that were never an issue before. So all of a sudden they start to survive and grow out in a finished product. What we also see is a trend to lower salt or sugar, and those are natural preservatives that really inhabit the microbial contaminants. So if you want to lower that to make healthier foods, you do need to keep in mind alternative strategies for preservation. And the same goes for healthy foods that contain probiotics, for instance, is also a novel trend. Of course, those need to survive manufacturing, they need to survive ingestion, so they need to be made very robust and very resistant. But it needs to be taken into account that eventually they'll end up in the chain again. So they'll end up in raw ingredients and then can cause problems in foods made from those ingredients because they're difficult to get rid of. So these are a few challenges that need to be taken into account.
So how can food and ingredient companies really tackle those challenges?
Well, as NIZO, we always advise a 5-step approach. So the first is identification, and the second is more characterization. Then you go to defining solutions for control. The 4th step is to really implement those solutions and validating them. And then the 5th is just monitoring and verifying that it's effective. And so if I go into those steps in a little bit more detail, the first is really identifying a potential hazard. And within this podcast, I'm focusing on microbial hazards. So am I dealing with a pathogen? Is it a food safety issue, or is it a spoilage issue? If you know the identity of the microbe, you can already deduct some information like, is it a spore former, a biofilm former, is it heat resistant or acid resistant, or is it able to produce toxins? Then you go to more the characterization and quantification of the hazard. So specifically for the example of toxin production, there's a wide variety in strains whether they can produce a toxin and to what levels and under which conditions. Yeah. So even if a microbe can be inactivated with heat, if it was able to produce a toxin already before it's inactivated and it's a heat-stable toxin, you might get rid of the microbe, but the toxin will remain. So there's still a food safety issue. So that information from steps 1 and 2, that really leads to potential solutions for control, and you can apply predictive modeling already to try and see what those solutions could be. And then in 4, you're really testing them, implementing them in practice, validating them, leading to number 5, which is just monitoring and verifying.
So I like your 5-step approach, and it makes a lot of sense. But do you feel that all 5 steps are always needed for a new product or for a new process?
Well, not necessarily. So it depends a little bit on the situation. If you already have a good process set up, and you're not running into any issues, then of course step 5, which is the final step, is sufficient. It's a standard procedure within food safety management to verify and monitor. But if anything is changing in that process, which could lead to potential novel issues, then we always advise to at least take all 5 steps to cover all aspects. And steps 1 and 2, they're fairly easy to implement. They don't cost a lot of time or a lot of resources, but they do provide a lot of information that is very suitable to then tell you whether steps 3 and 4 are actually necessary or not. So it's a little bit this type of approach that we would advise.
Okay, and if you look at testing it, what type of models or assays are used during those 5 steps?
There's a wide variety that can be applied.
Can imagine.
So basically what we often do is first we try to answer a couple of questions that may lead you into a direction of the most suitable approach or method. For instance, what is the type of food that we're looking at? Is it liquid? Is it UHT treated? Is it fermented product? Or is it a solid product with very low water activity, for instance? The second is, from what angle do you want to get the information? From a food safety angle, it requires a different train of thought than, for instance, more spoilage related angle. And then also the depth of the information that you need and that you're looking for. So if we're talking about, for instance, steps 1 and 2, identification and the characterization, there's various methods that are easy to adopt, cost effective, which give nice information like classical plating methods, maybe supported with identification through Malditov or 16S identification. It already gives nice information on what you could be dealing with, but they also have their limitations. Yeah. So the limit of detection is quite high, so you're not picking up very low abundant problem causes. Also, the level of resolution from this identification is quite low, so you would need whole genome sequencing or metagenomic sequencing to really get to that depth in strain-specific characteristics. Yeah. But these are more expensive, take more time, so not always necessary to implement in those steps. And the same basically goes for 3 and 4. The solutions for control, very low threshold is predictive modeling. You can make use of existing models and already get a good idea on what could be suitable. And then with high throughput screening on a lab scale, you can test all sorts of different conditions. But then that helps you to select a condition that you really do need to verify in practice. And then you go into more time-consuming and costly, like challenge tests, for instance, to really. So those together with those questions that I mentioned at the start will help you to define the most suitable approach.
Yeah, so there is a whole array of possibilities here, what you're describing. If we look at the future, what is the future of food safety and product development?
Well, René, I think two answers to that question. So the first would really be, I think the whole food manufacturing world could benefit a lot from implementing a more holistic approach already at the start of the development. I think a lot can be gained there. Really multidisciplinary approach, not only taking into account knowledge on ingredients or the product formulation, but also process technology and microbiology. And if that is done already at the start, you really help to prevent issues rather than trying to solve them real quickly after they have actually occurred. So I think there's a huge benefit there. And the second answer is more technical. So what I personally find very exciting developments is more in the area of sequencing. So I already mentioned sequencing as an approach. What we see here is major developments. It's becoming more accessible, it's cheaper, and I do think application of such sequencing techniques can be done more regularly, especially if you look into the development of these handheld devices that even allow for on-site detection already within 24 hours if that's set up properly. So I do see a potential there for the food industry. It's already being applied in other areas like more health and pharma related. But I think the health industry, the food industry, can certainly also benefit from these developments.
Well, thank you very much for your nice insights, especially the 5-step approach with a whole lot of possibilities to enter these steps, also looking into the future. So thank you very much.
You're welcome.
This was NIZO Talks Food and Health, and if you want to know more, please check out our website.
Thanks for your attention. If you enjoyed it, please check out our other episodes via our website and other platforms like Spotify, Apple iTunes, and YouTube. Subscribe through your regular podcast app to make sure you never miss an episode.